Welcome to the course Complete ASP.NET and Entity Framework Development. I'm your instructor, Trevor Williams. I've been a software engineer and lecturer for the past 10 years, and it is my absolute pleasure to teach you on this topic. For the duration of this course, you're going to be exposed to quite a few things. One, we're going to be building a completely data-driven web application. We'll be using the MVC pattern, we'll be using C# and .NET Core syntax, Bootstrap to manipulate the overall layout, and GitHub for our source control and tracking purposes. In accomplishing all of this, you're going to be exposed to Entity Framework Core and the Code First pattern, and we'll also look at some other development patterns like the repository pattern and dependency injection, also asynchronous programming. So with all of that said and done, I'll see you in the course. Hey guys, in this lesson we'll be installing Visual Studio 2022, which ships with .NET 6, which is the fastest .NET yet. So to get started, we just need to go over to visualstudio.microsoft.com/downloads, and then we will go ahead and hit the free download under the community edition, which will then give us an installer. So once we run that installer, we will be able to select the workloads that we want. Now, workloads really refer to the libraries or the supporting libraries for the type of app that you're interested in creating. So in this case, we definitely want to get that web development, ASP.NET, and web development workload. But then if you are interested in other technologies, you can go ahead and select them. So you can see I have several workloads selected with Azure development, Node.js, and desktop development. So you can go ahead and select those also. I think that they will come in handy with other projects that you might end up building. All in all, once you have done that, you can go ahead and hit install, which would be down by the bottom right hand corner. Of course, the more workloads you select is the bigger the download size. So once you've completed that, then you can continue. Now, when that download is finished, you may get certain options that I am not going to get because I already have it installed. So I'll just walk you through what to expect. You may get an option where you get to choose your theme. As you can see, I'm using the dark theme, but then you do have the option of a light theme, a blue theme. And the thing is that Visual Studio 22 has many more themes than its predecessors. So even if you don't like the initial themes, you can get other themes if you need them. Also, you may be prompted to sign in. So if you already have 2019 installed on your machine and you are just installed in 2022, you already signed into 2019, then it probably won't prompt you to sign in again. However, if this is your first installation of Visual Studio, you may be prompted to sign in or create a live account, at which point you would want to just use your Microsoft issued at live at Outlook or at hotmail.com account. Let us create our first .NET Core web project. So step number 1, open Visual Studio. I'm using Visual Studio 2022. Next step, go ahead and click create a new project. Now this landing screen firstly will show you recent projects. So if it's your first time, then you won't have anything to the left. So if it looks slightly different, don't worry about it. But what we should have in common is the ability to create a new project. Once we go over to that section, we'll see all of the project templates to the right, and if you recently used any, you'll see them to left. So if you don't see anything on the recent, once again, you don't have to worry. So under the list for the right, what we want is a web app, but I am not going to select web app because that would give me a Razor Pages app. In this particular course, we're looking at MVC pattern and development. So I can just type and search MVC, and then you'll see the one that we want, which is the .NET Core web app model view controller. Now on the next screen, you're going to be asked, what do you want to call the project? Where do you want to store it? And what do you want the solution's name to be? Now by default, when you start typing the project name, it's automatically going to change the solution name to match it. However, here you can see that I'm using two different values because I want to specify that the project is leave management.web. However, the solution is leave management net 6. So after you type the project name, you can just go down to the solution name and change that. If you don't want to use that default location for your repositories, you can always use the ellipsis and browse to your preferred location. Now, after doing all of that, we can hit next. And then, like I said, we want a .NET 6 application. Now, .NET 6 is the current version of .NET that is available, and it has long-term support. .NET 5, even though it says current, was like a transitioning period between the .NET Core 3.1 and a unifying period where they wanted to bring everything under an umbrella. Now, most courses would have been .NET Core 3.1 because that brought about an era of stability. .NET 5 unified, and now .NET 6 is the most performant and most stable and up-to-date version of the .NET versions. So for this course, we're going to be using .NET 6. I will, however, later on spin up a .NET 5 project and show you the minor differences between the two, but we will be proceeding with .NET 6 for this course. After you've specified the .NET Framework version, you can specify that we want authentication type to be individual accounts, and that will kind of scaffold certain bits of code for us. We'll see that in a few, and we can just make sure that it is configured for HTTPS. We don't need Docker, and then we can hit create. So when your project has been created successfully, and just to note, if you didn't see the project templates that were used or pointed out while I was going through the creation, then you probably want to go back to your installer and make sure that you have the correct workloads selected, namely the ones for ASP.NET and web development. So once in Visual Studio, you'll notice that, well, I have the dark theme running. You probably already have it or you don't have it. A quick and easy way to change that would be to go to Tools, and then you can just change it from here under the theme option. Another thing is that you'll notice that my Solution Explorer is to the left. Now, I prefer to keep mine to the left. Yours is probably to the right by default, but this is something that can be moved around. It's just a toolbar, so you can actually move it anywhere in these spaces. That's probably how yours looks, no problem. I like to have mine to the left. Otherwise, you'll notice that you have all the toolbars which you can actually click and extend, and they snap back into that hidden space. That's that pin right there, so you can toggle auto hide with any one of these toolbars at any given time. You'll have access to go and view other toolbars that might not be visible. So I've been using Visual Studio for a while, so I might have toolbars here that you don't have initially. If I have something you don't and you want to find it, more than likely you can go to view and then just look for it by name. By clicking it, that toolbar will then appear. When we're ready to run our applications, we'll be clicking that play button up top. So this one will run it in debug mode, meaning that we will be able to set what we call breakpoints and be able to step through each line of the code. We will see that later on. And you can also run without debugging, which is probably quicker and better for when you're just changing visual elements and you just want to quickly see how it looks. So as we go along, all of these things will make a bit more sense and the context will jump out a bit more as we do progress. Now, while we're here, what I want to do is add this to source control. So like I said, Git is what we'll be using, or GitHub is the platform that we will be using as our source control platform. So what you want to do is every time you spin up a new project, even if you're working by yourself, you put it on a source control management system. And then each time you hit a milestone or you make certain changes, you go ahead and check those changes in or commit them so that you can have a copy of the last working code file. So at this point, this works. What we're going to do is just look to the bottom right hand corner and you see add to source control, and you should see Git. Once you click that, you might get prompted to log into your GitHub account through the Visual Studio interface. So you can go ahead and do that. I'm already logged in. So all it's asking me is, what is the name of the repository? And give a description, and do I want it to be private or public? Private means that unless you have credentials to my account, you won't be able to see the project. So this will be better for maybe your school projects or your enterprise projects or any personal project that you don't want to necessarily share with the world. You want to leave it as private. However, for anything that is okay to share, like my source code for this course, then I can untick private, and then this would be the URL to that project on GitHub. At this point, you can also customize the repository name. So by default, it's going to take the name of your solution. I just kind of modified it because I have other leave management projects on my GitHub. So I just want to make it kind of distinguished based on its name so that it's clear which one it is. I can also put a quick description. So that will let anybody who visits this repository know that it's a leave management system built with .NET 6 for educational purposes. Once I'm finished customizing all of that, I can click create and push. Now, before I move on, you'll also notice that you have Azure DevOps. So Azure DevOps is Microsoft's source control management tool that you can also get access to through your live account. And it takes a bit more to set up, and people don't necessarily interact with it at a public level as much as they would with GitHub. So that is why I'm choosing to use GitHub in preference to Azure DevOps. That being said, Microsoft owns both of them, and the integration between them and Visual Studio is very, very good. So whichever one you feel more comfortable using, and probably for a company setting, you would probably want to use Azure DevOps more, but that is okay. We'll just use GitHub for our educational pursuits. So create and push. Now, once that operation is done, you'll start seeing some little icons appearing beside your files in the Solution Explorer. These padlocks mean that the code file has been checked in. And when we start making modifications, you'll see that they change. When we start adding files, you'll see other icons. We'll go along. As we go along, rather, we will see those. I'm not going to give you information overload. So that is really it for setting up Visual Studio, creating your project, and getting it up on GitHub. In this lesson, we're going to take a look at doing our first migration and what that means, how exactly it works, and what we get out of the box. So the first step to understanding migration would be one, what is the application connected to in terms of a database? So we need to have a database connection running in our application. If you remember, in app.settings.json, we saw that. We have something called a default connection, which is looking for a server by that name. So this server, localDB, is the localDB database server that came with Visual Studio. If you want to use another database server, meaning you probably have a local host or an SQL Express, then you just need to change this value. So if it's localhost, you can just say localhost. If it's an IP address, you put in your IP address accordingly, right? If it is maybe SQL Express, then you would be able to say localhost // SQL Express. You have to put 2 slashes based on the syntax. But my point is that whatever the server is, you can put that there. For now, I'll just continue with the default MS SQL local DB server that came with Visual Studio. Next up is the name of the database. So they generated a database, which is a combination of a GUID and the project name. I guess they did it that way just to make sure that it doesn't clash with an existing database. But if we want a cleaner database name, we can always change that. So we can say database is equal to leave management, and I'm just going to say net 6. I'm only doing that because I have other databases with similar names. So I'm just going to specify that this is the leave management database for our .NET 6 application. The rest of the options you can leave. This one means that a little security should be applied to the connection, and this one means that multiple persons should be able to connect to the database when they need to go ahead and carry out certain operations, right? So that is our first change. We need to know what we are connecting to. Now we know that. Next up is to look at our migration file. So under data, you'll see migrations, and this is a file that came with the project because we indicated that we wanted individual accounts for sign up and sign in purposes. So create identity. Basically, this is going to scaffold. I'm sorry, I was looking for the proper word. So it's going to be scaffolding certain tables for us inside of the database that we have indicated. If you look very carefully and closely and you apply a little of your C# knowledge, you would notice that even though it looks complicated, it's not really that complicated. This is saying that it's building a migration, right? Migration builder, that's the object. This migration builder is going to create a table with the name ASP.NET Roles, and the columns in the table should be ID, name, normalized name, etc. The table.column should be a string and it shouldn't be nullable, right? That's all it's really saying. So it's column, what kind of column? It's a string column. Those are the parameters for it. And if you just scroll through, you notice that that's all of the lines are saying. The next major thing would be that it's adding a constraint where it's saying the primary key for the table that is being built in this line is the ID column, right? That's all it's really saying. So it's creating a bunch of tables for you to facilitate user login. So you see you have roles, you have claims, you have users. I'm not going to get into the details of every single one of these tables. Some of them will be used definitely, and we will explore them, but this is what comes out of the box for you. So in a nutshell, a migration contains instructions for what should happen to the database. And this one is our first migration that we have. So to carry out our migrations, now we're going to go to what we call the Package Manager console. So if you don't see it at that point of your screen, you can go to Tools and then go down to New Get Package Manager, and then you'll see the console. So you can go ahead and launch that. And then in this console, what we're going to do is run a command that says update database. So the reason we can do this is, one, we already have a migration. So when we start making our database changes, then we're going to have to add a migration, which means create a file with instructions to carry out the changes we want now. And then every time we want to actually change the database, we would say update database. So that way we don't have to go into SQL Server and create the database and everything initially. We can actually just write C# code, and then it will just forward engineer that code into the database. So here I'm just going to say update database. What that is going to do is make sure that there are no compile time errors, in the project. And then it's going to look for the instruction file, look for the database, and then it is going to start carrying out the operations. So you see here it's going through. And when all of that is successful, you'll see it flag it as done. And if you scroll through, you can probably read and see that all it did was translate these instructions into standard SQL syntax that we all know and love. Now, to prove that this has actually happened successfully, we can go to our, well, not Server Explorer, I want the Object Explorer. So I would go to View, SQL Server Object Explorer. And then once that pops up, it allows me to interact with the databases. So it's kind of awkward where it is. I'll move it and kind of pin it there to the pane with the others. There we go. All right. And then I'll explore. So that is the local DB/MS SQL local DB, or whichever database server you pointed it to. But if you're using the default one like I am, then this is how you get to it. So you expand that, then you look for databases, and then we're looking for the one with the name. Here it is. So you see, I have a bunch of databases. I've been a very busy developer, but the point is that this is the one that we just created. And sure enough, here are all of the tables that we expected to be created. So here's the roles, here's users, etc. So all of these tables came out of the box, and they are used to store our user information. So let's take a look at what is in the users table. So if I do a right click and say view data, well, there's no data to view, but we can see all of the columns. So we have a username, normalized username, email, password, and some other concurrency and security fields. There's nothing much there. So in a typical situation, if you're doing a leave management system, you'd probably want more information on your users, right? So you'd probably want like a first name, a last name, date of birth, maybe a tax ID, etc. So what we want to do in this exercise is to extend the users table, and by extension we can use that technique to extend other tables that are involved in the identity by default. So I'm going to go to data, I'm going to add a new class, and I'm going to call this class employee. Now this employee is going to inherit from identity user. So inheritance means that it's copying all of the classes, properties, attributes, etc. into this one. So whatever you're inheriting from is sharing with this one, and this one is just what we call extending the one that's being inherited. So I can use control and dot, and that will bring up that little light bulb. You could have clicked the light bulb, of course, but control and dot is so much more convenient when you're typing. And then you'll see that the first suggestion is that we need the using statement for that library. So we add that library, and then that red line goes away. So from here, we can actually add a few more fields. Now, Visual Studio 2022 is so cool. It's actually suggesting fields that could probably go in something like that. So I have name, I have email. What else does it have for me? Nothing else. That's a shame. All right, but I have my own fields that I want. I want string first name, last name, the tax ID, the date of birth, and the date joined. All right, so those are the fields that I want. Now you see here it's telling me about non-nullable. What I can do is just use a question mark there to make it a nullable type. So that means that it is allowed to be null in the database. Without that, it is not allowed to be null, but then string is kind of weird with the nulling and non-nullable stuff. But that's fine. I'm going to leave these like that and ignore those warnings. So this is how I would indicate that I have a custom class called employee that I want to mimic the default user. So now that I've made this very simple change, I need to now let the rest of the application know that this is the user class it should be using for all of its operations, right? So when I go to the program.cs file, now we can look at this with a bit more scrutiny. We can assess the first few lines and see that one, it's creating the connection string, right? Or it's retrieving the connection string. So builder.configuration. Configuration here represents our configuration file in the form of app settings. So it says get connection string by the name default connection. So that is how it knows which database. Then it's going to say add a DB context, and we'll get into what the DB context is, but you'll notice that that is just a class file that is also in our data folder. So anytime a file is open and you want to find the physical file, you can use the sync to file or control square bracket S, and it will jump to the file. So that's another quick quick win for Visual Studio navigation, right? So that is a DB context, which is like the bridge between the database itself and our code. We'll see how we modify that in a few. So we're saying get the DB context relative to that bridge using the connection string as found in the configuration, right? You see how everything is just connected. And when you see how things work, you start opening up your eyes and saying, oh, that's what this thing is doing. Now, further down, we have this option that says add default identity. And then it's adding default identity relative to identity user. So identity user, once again, is that default user class, which is what was being used to scaffold the ASP.NET user stable. However, if I now tell it that I want you to add default identity relative to employee, which is our new class that indicates what a user is, then everything that is user related will now expect employee instead of identity user. Now, the next thing that I need to do to let the database know that it should now see extra fields. So this is really just for application related operations. But if I jump over to the DB context, I would notice that it is inheriting in identity DB context. So there are two types of DB contexts that you might see. You see DB context, which is the regular one that just means, oh, I'm just a regular database. So standard ASP.NET Core applications that are not including identity out of the box will use just DB context. However, anytime you want the user-related tables, you have to say identity DB context. And then this can be extended to say what specific user type should I be using. So when I use my angle brackets beside it, you see that Visual Studio is now suggesting that I need a class called TUser or of type TUser. So if I paste employee, then that red line goes away because employee is inheriting from identity user, which is that TUser type it's expecting. So if I removed this inheritance and went back over here, then I would just get some error line here because now it's saying it can't identify with what I want. Employee is not of type T identity user. So I'm just showing you these little things because if you miss one step, it could lead to hours of debugging when it was really simple to begin with, right? So that is why we inherit from identity user on the employee class, and then we let the DB context know that the identity DB context should be relative to employee. And we also need to make sure that our program CS knows that everything identity related should be relative to employee. So when we do all of that, I can do Control Shift and B just to do a build to make sure that nothing is broken. There we go, one successful. And then I'm going to go over to the Package Manager console, and then I'm going to add a migration, and I'm calling it Extended User Table. So it's add-migration space extended user table, or whatever it is you want to call that migration. Once again, you want to be descriptive. So when I run that migration, it's going to build again. Then it's going to generate one of those instructional files. This time it's not create table, but add column. So this time it's saying it's adding this column to that table with that data type, and it's not nullable, and the default value should be that. And it's doing the same thing for the tax ID, the first name, and the last name, right? Because I didn't make those nullable, remember I showed you that in employee, I should have done that to get rid of the warning. Because I didn't make it nullable, in the generation of the instructions, it's saying nullable is false, right? So it can't have a null value. So those are little things that I want to point out. Those are little key elements. All of those things come together to build your application. So when you know, the more you know is the more you're able to do. So now that I've done this migration or generated this instructional file, my next step is to update database. Now, before I do that, if I made a mistake with the migration, maybe when I look at the instructional file, it's not doing exactly what I wanted it to do. For instance, maybe I did want these to be nullable. Then I can always run the command remove migration, which will actually undo that instructional files generation. So you see it disappear here from the migrations folder. And then I can make my changes. So let us say I do want them to be nullable. So let's change the data types here, save, and then Package Manager console, I can use up to get back most recently run commands, get back that command for the migration. And then when that file is generated, now you'll see that it is saying nullable is true. All right. So I'm just showing you little things that come together. So after all of that, I can do my update -database, and then this will go through and apply the changes to the existing database structure. So it's not going to recreate a database for me. It's just going to apply the changes, right? So once I've applied those changes, let us take a look again at this table. This is the user's data table. If I refresh that, okay, no, I'm going to have to do a fresh query. So let's go back to our SQL Explorer and view data again. And then, okay, let's close that one, sorry. And let's try that again. So view data, it's going to do a fresh query, and then it's going to show me all of the columns in the table. So now I'm seeing my date, join, date of birth, first name, last name, and the tax ID all added to my table. Right, so that is how you can go about extending your identity. That's how you extend your user operations, and in general, that is how you do migrations and update your database. Now, once an update has been applied, you cannot just remove migration. If the update is applied and you made a mistake, here you can either correct it and make another migration, and for every change that you make and you want applied, you just create a new migration and update the database. And as best as possible, EF Core will try its best to take care of that for you. So when we come back, we'll look at how we start creating other tables, because we spent all the time looking at just the user table. Now we need to actually look at creating our leave type table, or leave history table, etc. So when we come back, we'll get into all of that. So we just finished extending our user table. Now we need to create our other tables that are not necessarily identity related. So the simple task of creating a new table goes like this. Create a new class to represent the table. The first class or table that we want to model out in the form of a class would be the leave type, right? So leave types, those represent what the categories of leave are in the system. So I'm going to add that as a class file. And it's a typical class, as we know. We're going to have to give it the properties that should translate into the database columns, of course, with the appropriate data types. So once again, we saw that coming from the employee, because with employee, we had string, which translated into nvarchar were necessary, and we had datetime, which the database converted to datetime in its own way. So I have to make sure that we use data types, even though they're C# data types, but they have to translate into the appropriate SQL data types. So certain rules that if you follow them, they will make your life very easy when it comes to interacting with Entity Framework Core. Rule number one, you should always have a primary key. I think that's basic database design. You always have an ID column that auto increments by itself. You don't put the value in there. You don't worry about the value until you need to run a query against the value. So it is autonomous. So Entity Framework Core has two ways of allowing you to put in such an autonomous column. Way number one is that you put in a public int property called ID. Simple. Get and set. That's all you really need. Way number two is that you append or prepend the table's name on ID. So if I said ID by itself, that would be fine. If I say leaf type ID, Entity Framework would also see that as the ID column. Now, personally, whenever I build databases, I like to see ID because I don't like to prepend the table name on columns because it's obvious that this column is already in the table. So I have a table called leaf type. My column is going to be called ID. The next column that I would want for the leaf type would be for the name, the name of the leaf type. Is it sick leave? Is it vacation leave, etc.? Next, I would want maybe default days, because based on the number of days that or each leaf type, generally speaking, has a default number of days that you can get. So I'm setting up default days to say vacation, you get 20 days for the year, or you have up to 20 days for the year. Sick, it's 10, etc. So my leaf type is going to have an ID, a name, and default days. Once again, you see the little warning here with the string, but then I don't have to heed to that warning necessarily if I control it from my application. We'll deal with that later on. Another thing that I want to add is something like an audit column. So I want to know when it was created, and let's just say I also want to know by whom it was created. But let's work with date created and date modified for now, right? So later on we can extend it. So leaf type, we want to know the ID. That's going to be taken care of automatically. We will allow our admins to enter the name and the default days it should have in the system. And then we are going to be tracking in the backend when it was created and when it was last modified. The next one that I'm going to create is the leave allocation. So we're going to go add new class, and we're choosing leave allocation as its name. Now the same rules will apply. One, what is the ID? So I'm going to indicate that. Two, what are the audit fields? Well, I actually want it to have the same kind of audit fields as the other one, right? So anything that's in common, I'm just going to place there from now. So for leave allocation, we're talking about an employee having a certain number of days allocated to them based on the default days of the leaf type. So that's what number of days is for. Now, I mentioned that it would be relative to a leaf type. So that means I need what we call a foreign key. So if you know database development, you're familiar with foreign keys. If not, then a foreign key is basically a reference to a primary key of another table. So from leave allocation, I need to know for which leaf type is this employee allocated this number of days. So we have the leaf type table. It has its own ID. I need a reference of this ID from this table over in leave allocation. So that is going to require two things. One, I'm going to have to include an entity that represents, or a property rather, that represents that other entity. So I have a property called public leaf type, and this is going to represent that I am connected to the leaf type table. It also will allow me to get details and facilitate inner joins much more easily. The next thing I need is the actual column that represents that foreign key. So notice the naming convention now. That is very important. Let me put space between them. One, I am naming the foreign key exactly after the table, followed by the ID property. Entity Framework Core is going to see this pattern and just know off the bat that this represents a foreign key relationship with that table. That's how simple it is. So that's why I said I'm pointing out little rules that will make your life easier, because Entity Framework Core is there to help you. If you want, you can actually also append a data annotation to it that will help you to point out that this represents a foreign key. So you could do something looking like this. So data annotation is open square bracket, the name of the annotation, and then in this case it's foreign key, which takes a parameter of string with the name. You'll have to include that using library. So because I pasted it here, it automatically added the using. But generally speaking, you can always use your control dot when you see that red line. Just use up your keyboard shortcuts, press enter, and you get your using statement. So I'm going to leave that there just so it's very explicit that this is a foreign key. Another foreign key that I'm going to want to add is to the employee table. So remember that we need to allocate this leave type to an employee, and we're giving them that number of days. So I will be including another field called employee ID. Now I'm not going to make this one a foreign key, and I'll explain why later on, but this is just going to store that ID reference to the user that will be created in our table. So let us summarize leave allocation. We have our ID column. It has number of days. We have a foreign key pointing to the leave type for which this allocation is being made. We have the employee to which this allocation is being attributed. And then we have our audit columns in the forms of date created and date modified. Now, I think I'm going to stop for now because there's another table that we do need to create, but I'm going to leave that for now until we get to that module. I think this is quite enough changes to our database for now. So after we've created these files and we've done the modeling, we need to now let the database know that these tables should be included in its structure, right? Remember that when we're modeling these classes, we're also thinking about how we would build the database tables. What are the columns we want? What are the data types we want? What are the foreign key relationships, etc. Now, after modeling them, I'm going to jump over to the DB context. And in the DB context, I'm going to, inside of this class file, underneath the constructor, I'm going to have prop. So I can say prop and press tab twice, and that will just generate that whole line for me. That's another keyboard shortcut that you can look into. So I'm going to have DB set, and I'm going to give it the class name that represents the table, right? So the design of the table here is based on leave type. That's the name of the class. Then in my property, I'm going to give it the name of the table that I wish to be generated. So I generally pluralize my tables, and it's good practice. The jury's out on whether it's good practice or not. My opinion is that it should be pluralized. I'm not saying it's the best practice or anything, right? So here I'm saying create a DB set, which just means a collection of objects of type leaf type, and wherever I want this collection from the database, I will be calling it by the name leaf type. So that's what it translates to in code. In the database, what it translates to is create a table modeled off this class and call it leaf types. And then, like I said, this file, application DB context, is really just a bridge between what the database tables look like and are capable of and what the C# code wants to see from the database. So I'm going to do the same thing for leave allocation. So if you want to duplicate a line, you can just hold on Control and press D, and it will duplicate that line for you. And we can say leave allocation. That is the next table, and the table name should be leave allocations. Now, with those changes made, I go back to my package manager console, get my add migration command, and then this time I'm going to say added leave tables, and then press enter. And then we get another migration file. So this migration file is one that is saying create table because these are new tables being introduced. So it's the same syntax as the initial migration. If you look in the folder, you see that you got that other migration file that has that timestamp on it. So you know exactly when and where to some extent it was generated. It has its name there. You see the name here, right? I'm just pointing out how all these things are connected. So we have the create table, leaf types, and then all of the columns. So you see here on the ID column, because I made it an int and I called it ID, EF Core in generating the instructions automatically knows that it is an int that shouldn't be nullable and it should be identity, right? So all of those key phrases are coming from SQL Server. Identity means that it will count by itself. Also down here, you see they add that primary key constraint. Later down, you also see that in leave allocations, it does the same thing for the ID, and then it sets the primary key, but then additionally, it's setting that foreign key, right? So the foreign key here gives it a name of the constraint. It's telling it that the column leaf type ID, see, its principal table for the relationship is leaf types, and the principal column is ID. So in other words, create a foreign key between this and this from that table. That's all. If you remember how to do all of that in SQL Server, then you know that this is doing nothing special. On delete, it is saying that the referential action is cascade. Now you can change this. Cascade means that if I delete the leaf type, then every single allocation associated with that leaf type would also be removed. I don't think that's safe, right? So I would actually want to restrict the deletion of the leaf type before it removes all of the related stuff. So I can change this from here, from referential action cascade to maybe restrict, no action, etc. So I'm going to say restrict because I want to prevent you from removing a leaf type that is currently allocated to an employee. So I'm just showing you changes that you can actually make to the migration file. And then once you're satisfied, so you always want to check this over just to make sure that everything is in keeping with what you expect. Then you can go ahead and do an update database. And once that is done with no errors, then you can proceed. Now, the last thing that I want to point out before we move on to the next activity is the fact that we have certain repeating columns. And in programming, we have the concept of dry. Don't repeat yourself. What we're doing here is repeating ourselves because we know that every table needs to have an ID. And so far, we're trying to make sure that every table has that date created and date modified. So we have at least 2 tables. And if we have more tables, they're going to at least have the ID. And we would want them to have that. So what we do sometimes is create something like a base class. So I'm just going to create class and I'm going to call it base entity. And this base class just means these are standard things that everybody else can inherit from. I also generally made this a partial class because I don't want anybody to be able to instantiate the base entity by itself. So that's what partial means. You can't do this by itself. It has to have an inheritance working with it. So I can say base entity should have ID. So I'll cut ID, paste there, and it should also have date created and modified. So every entity, every table that we're going to create or entity, right? Every one of them should have these base columns. So I can now say that leave allocation, you should inherit. I hope you completed that sentence. You should inherit from base entity. And then I can do the same thing for leaf type. So look at what happens when I set the inheritance for leaf type. When I do that, then you see these now getting highlighted because now it's saying that it's seeing 2 instances of that and it doesn't know which one to use. Well, by default, it's going to use this one, so it may not ever use that one. That's fine. So I'll just remove what is duplicated. And then that's a nice, easy way to keep your entities clean. So once you get over the fact that everybody needs to have an ID, and we looked at that just now, make sure you give it ID. It will automatically see it as a primary key. We have other fields that probably should be common across all tables. Instead of repeating them every time you have 20 tables and you're saying ID 20 times, you just do it one time and then you set up your inheritance across all of the benefactors. That way you keep it consistent. If you have to change this, you change it one place for everybody. So I'm just going to do a build, and that build was successful, so I have introduced no errors. All right, so the first thing on the menu is the scaffold or CRUD functionality for our leaf type module, right? So scaffolding means that we're generating the code. So I would have used that word a few times when we were talking about what came with the project and how we had the first migration and the tables were there for us. Those were generated for us. That's what scaffolding means. So thanks to Visual Studio and the .NET framework, generating certain bits of code is very, very easy, and it's easy to get a fully functional application up and running almost out of the box. Now, to get our, let's say, CRUD up and running for leaf types, what we need to do is we start with the controllers folder. We go to add and we want a new controller. And then the first option that we get says, do you want an empty controller? Not really. Do I want one with read and write action? That could come in handy if I had specific things that I wanted to write and I didn't want to scaffold. However, the last one says, get the controller with the views using Entity Framework. Now that one looks pretty cool to me. So I'm going to go ahead and click Add. And then that is going to ask me a few questions. One, what is the model class? So the model class means, remember, model really represents the data. So what data should I be using as the basis for the scaffolding that is about to occur? So if I'm dealing with leaf types, then the class that I'm looking for is leaf type class, because that is the class I created that models the data. Next up, what is the data context class? Well, my data context class is application DB context. So I'll choose that one. Then it's going to ask me, do I want to generate the views? I think that's a good idea. I might as well. Do I want to reference script libraries? I am not going to, because I really don't need to. My layout file has all of those things referenced in it already. And do I want to use a layout page? I can leave this empty because it's going to use the view start file. And remember, in the view start file, it does say underscore layout. So I am going to say use the layout page. Next, what is the controller name? So you see the naming convention obtains. Because I chose leaf type as my model, it is automatically inferring that I want a leaf types controller, which is a good inference to make. So I'm going to go ahead and click add. Then it's going to download a few more libraries, and then you see the keyword scaffolding. So give that a few seconds. And then voila, we get a controller file. Now, this controller file has a lot more code than we would have seen in the previous files. And I'm going to walk you through every single line so that you understand exactly what is happening here. So, one, it generated our controller called leaf types controller that inherits from a base class called controller. If you looked at home controller, you'll also notice that that inherits. So like we did with the base entity and the other classes inheriting, that means that controller has certain features that it's just sharing with anything else that needs to be a controller. So if we remove this, then that would actually destroy quite a bit of the functionality that we're expecting to have. So you see all of those red lines start appearing because the controller no longer has access to certain things. So that's why we inherit from that base class. The next thing that is happening in these 3 or 4 lines would be what we call injection or dependency injection. So application DB context, that is our bridge to our database. That is housing all of our tables, all of the everything, all the instructions needed to talk to the database. We're instantiating it. However, you'll notice that the constructor, this is a constructor, right? It is also taking a parameter of the same data type, and then it is initializing the field. So that's the field. It's initializing it to be the value of the parameter being passed in. So what's happening here is that in the program.cs, in this section of the code file, it was actually initializing that the DB context should be added to the service wrapper for the entire application. So once that is done, it means that anywhere in my application that I need to connect to a database, I just need to do something looking like this. Create a constructor, add application DB context, and whatever name I give to it, it really doesn't matter what name I give to it as long as I have the data type and the object name, and then initialize a private field in my code file, and that will actually take the connection to the database and place a copy of that connection inside of this controller. So every controller that needs to talk to the database just needs to do this, and that is what we call dependency injection or dependency inversion. It's one of those solid principles that makes code as clean as possible and as efficient as possible. So after it finished injecting the copy of the connection to the database into the controller, then you'll notice that these are just actions. So if I do Control M and O, it will kind of collapse everything in the code file. Control M and O. So let me go through them one by one so it doesn't look so crowded. So let's look at the index. So you see here that it's the same structure as what we saw with the home controller, right? Public, action result, index, and it returns a view. So in our new controller, instead of just that, we also have async task. So by default, you can get access to asynchronous functions very easily using the new .NET framework. And as we go along, I will point out what is asynchronous and how it is more beneficial towards what we need to do. So here we're saying this is an asynchronous task that returns action result. So this is very important because that allows us to return view. And it is called index. Remember I said that every controller or every page or set of pages must start with an index file. So index action is very, very important. So we have the index and then it returns a view having made that call to the database. That is a call to the database, right? So all we're saying is await, and we're saying await because we're doing async. So anytime you're in an async method and you're going to be calling something else that is async, right? Then you have to prepend that function call with the word await. So if I didn't await that, it would get an error, all right? So you see here, it's giving me a warning that it needs the await keyword. So you just make sure to put await. Don't worry, as you go along, you'll catch up on that pattern. So here we're saying, go to the database. Context is the database. Go to the leaf types table. How do I know that's a leaf types table? Because we named it leaf types. If I control click, you'll see it navigates to the very line that we put in. That's our line. And by doing this, we said leaf types is connected to the leaf types table in the real database. So I don't know if you had gone over and actually looked at the tables when they got generated. I didn't do it, so let me just do it quickly and show you that this is not a sham. It actually works, right? Then you'll see that we do have the leaf types table. So leaf types is connected to our DB set here, which is then being used in code whenever we need to talk to the leaf types table. So right here, database, get me the leaf types table, and everything that is in it, convert it to a list. So you'll see a lot of that happening in C# to list. After database call, you put it to list, and then you can use it to do what you want. That basically translates into select star from leaf types. That's all this line is doing, all right? But instead of writing SQL and then writing 5 other lines to convert it into this and connect to the database to that, this one line connects to the database, looks for the table, and then gets the results from the table. And that's really it. So that's the power of Entity Framework Core. So this could easily have been put into a variable where we said var leaf types. And you'd probably want to do it this way to kind of break it out, is equal to, make that database call, and then this object represents the data coming back from the database. And then when we're returning the view, we are giving it the data. So that's what we mean by the model, right? Leaf type, that's the model. This is our model right here. And it's returning the view with the model or the data. So controller is returning the view with the model. All right, so that's how all of them get connected. So I think we understand the syntax surrounding the actions now. So public async task action result. This action is called details, and it takes a parameter called ID. Now this is a nullable int because if no ID value is provided, then we just return a not found or a 404 page. You ever went on Amazon and clicked on a product and then they say, oops, this is embarrassing, you can't find it. That's what a not found is, right? So if you try to go to the details page and the ID didn't exist or it was null, it just tells you it couldn't find that record. That's what this does. Later down, it says, try and find that record in the database. So it's going to say leaf type, just the same way that I just ripped out this and assigned it to a variable. Here, it's actually starting off with a variable. Leaf type is equal to, please go to the database, look in this table, and find the first record And remember that this is async, so the await matches the async. So find the first record where the ID of that record matches the ID being passed in through our request. And that is what that link would look like in the browser window. We'll see that later on. Now, if it did that query and the query came back empty or it returned null, then we give the not found. So it's either this is null initially, or after we try to find a record that is null, either one of them will return not found. If neither situation happens, then we return the view. So you can pick up on a certain pattern. We want to check for the bad scenario and then take an action if the bad scenario is true. So if bad scenario number 1, then return. Otherwise, it will move on and try to do that. If bad scenario occurs here, then do that. If neither bad scenario occurs, then we do what the user expects us to do and show them the data on the page. All right. Once again, that data is present. Now we move on to the create. Create, it's just a form. We're just going to return the view. Nothing else needed here. However, we have a second create, which is going to take all the data from that form and it is going to perform a post. So if you ever worked with forms, you would know that you have the get and the post method. Post means that it's not going to spit out every single thing that was entered in the form in the URL. It will kind of hide it and send it over in the request body. So that's why you have create here, and then you have create with HTTP post. The post version takes the data that is expected. All right, so we'll look at how we can modify this later on, but for now, that is what you get out of the box. So it's taking that data and is binding each field coming from the form to the matching fields in that data type and storing it in that object called leaf type. Then it's checking if it's valid. We'll look at that later on. If it is valid, go ahead and add it. So database, please add this record and then save changes. So anytime we're modifying data in the database, we firstly state the type of modification we're doing, and then we tell the database, save the changes that I've just made. So until we call save changes, that modification is not going to be made. Afterwards, please redirect to an action called index. So name of index is a very compile safe way of typing out index, because I can easily do that, right? But then if I do this and I had a spelling error, bad spelling error. If I had a spelling error, then you would spend time debugging, wondering, why isn't it loading? Why isn't it loading? So at least this way, if I have a spelling error with index, it's not going to proceed because there's no such thing as that in code, right? So this is just basically turning that code into a literal static string. That's what name of brings to the table. So if none of this happens, or if it wasn't valid, then it's just going to return the view with the data that was just submitted, right? So, like you fill out a form and you press enter, but then it bounces back with the same form with the data with like validation errors to say, hey, this was wrong, blah, blah, blah. That's what this is doing. So I'm just giving you an overall tour. We're going to go into each one and make modifications soon. Edit, this is going to look very identical to details. So if you compare edit to details, you'll see that it's really the same code. We want to edit a record. If the ID is null, we didn't find it, we search for it. I notice that this time it's saying find async and it's just passing in the ID. So that's just an indicator as to how much easier life is when you actually give your tables a proper ID, right? So it tries to find it. If it can't, return not found. Otherwise, load the page with the form with the data accordingly. Otherwise, it has the HTTP post, just like how create has the form, just the get and the post, one to show the form, one to get the data. Edit does the same thing. And the code here is slightly different because it's making sure that the ID is matched first of all, then it's making sure it's valid, and then it tries to update and save changes. So this is the change I want, and then I want to save that change. And then it checks to see if there might be any issue, like if two persons are editing the same record simultaneously, that would cause an issue. So that is what this exception would be about, and it takes some actions there, and then it returns to the index page if that was a successful operation. So if the try was successful, then it returns to the index. Otherwise, it reloads the form with the data that was submitted. Delete looks just like the edit and the details, getting the record. And then the delete confirmed basically says that you've confirmed you want to remove the record, find the record, remove it, and then save the change, then reload the index page. Otherwise, there is another method down here that's not an action, it's just a method. So that just goes to show if you need to write custom methods in your controller, you can. They don't always have to be actions. So this is just a value returning method that's checking does the leaf type exist, and all it does is return true or false. So this one says context.leaftypes.any. So here you'll notice that you have different kinds of methods that you can put after database table. What do I want? So database table, I want to remove. Database table, check if any, and then that takes a Boolean or a truth expression and it returns a Boolean. Here we see find first or default. And up top, we found this one that says bring back the records. So that is essentially what we call link. And link is used to interact with Entity Framework Core, which in turn translates these commands into SQL statements. So that is just an overview of how Entity Framework interacts with our controllers and helps us to run queries quickly to retrieve our data and do what we need to do. All right, guys, welcome back. So now we're going to take a look at how the delete function works. So what happens is that when we click delete, it goes to a page showing us the details. Are you sure you want to delete this? And then when we click the delete button, it submits a form. So that happens for a number of security reasons, where that form submission has to be validated, as we've known, with the anti-forgery token. Let me just jump over to the details of it in the controller. So here we go. So this is the get, right? Very similar code to details and edit. Just getting the record, returning that data to the user for confirmation. Then it says once the form is submitted, is looking for HTTP post, action name is delete, and there are a number of reasons they do this. So reason number one is that they can't have two methods with the same name and the same parameters. Both are asking for int ID. So that's why one has to be delete and one is delete confirmed, as opposed to their counterparts like edit, which has edit and edit, but they have two different parameter sets. So they are successfully overloaded. Same thing for create. Parameters are different. There we go, right? So that is why you'll see delete up top and delete confirmed below. However, it's letting it know that I'm overriding the action here to be a post that has the name delete. So it's still going to, the browser is still going to look to this method using the address delete. Notice that both URLs look identical, however, one is get and one is post. It's going to validate the anti-forgery token to ensure that nobody is trying to spoof a delete request. And then once it goes down here, it's going to find it by ID and then remove it from the database and save changes. So that is what is happening in here. So our modifications. One, I'm going to kind of bypass that confirmation page. For me, if I'm looking at it on the index and I want to delete, I'm going to want to delete. Now that's easy enough to do, but then I also probably still want to put in some form of confirmation prompt, right? So what we're going to do is integrate a library called Sweet Alerts, which is then going to say, are you sure you want to do this action? If they click yes, then we proceed to just make a direct call to the confirmation. So I'm jumping over to our index page where most of the action is going to happen. So we're going to have to write some custom JavaScript to make all of this happen, right? Now, once again, let's look at a little background. I want custom JavaScript to run on this view, which is the index view. However, in the layout, we know that we have a section where we're including all sorts of JavaScript. We have jQuery JavaScript, we have Bootstrap, and we have the site.js. What we also have is a section that we are allowed to render in any other view. So this renders the body of the view, and then I can now say in any view, I want to render custom JavaScript in that section. So what I can do inside of any view, in this case, the index view, I can say @ scripts. Sorry, I would say @ section, and the section name is scripts. There we go. And then open and close. And then inside of that section, I can now start writing my custom JavaScript code. So JavaScript always starts off with a script tag. And then in there, I would have my jQuery initializer. In this case, I'm just going to start off with a function, and that gets a function block, ends with a semicolon. And then inside of this function, I will start writing anything that is related to JavaScript, jQuery, etc. So I did mention that we're integrating with a third-party library called Sweet Alerts. So let us jump over to our www root. And what I'm going to do instead of that is right-click and, let's right-click the project, and then we go and manage client-side libraries. So click that. Oh no, that's not the file. That file will get generated eventually. What I really wanted to do was go to add, I apologize, and go to client-side library. So when we do that, then we get this management tool. That's what I'm after. So the library that I want is Sweet, and then start typing, and you see autocomplete is kind of suggesting things to me. So Sweet Alert is fine. So I can get Sweet Alert, and they'll tell me what library files I'm getting, and they're going to put them in the www lib Sweet Alert folder. So I can just go ahead and hit install, and there's that file getting updated right there, right? So then this file is just keeping track of what goes in. And you see it's just another JSON configuration file. I don't really need to interact with it, though. I just need to confirm that my library is now included. So now that I have this library included, what I'll do is add it globally at the layout level, because other pages might need to use a Sweet Alert. So I'm not going to make it local to any one view. So I'm going to include it the same way that we included Bootstrap and the other things there. So I'm just going to duplicate that line with the Bootstrap. Once again, Control D duplicates, and then I can just fill out the rest. So it's in lib in a folder called Sweet Alert. It's not giving me the prompt, I guess, because it hasn't built just yet. And then it's going to be sweetalert.min.js. There we go. All right, so I'm including the reference to the Sweet Alert folder, library rather, globally in our layout file. Order matters, so make sure that anything that you're doing, generally speaking, should come after your jQuery and your Bootstrap inclusions. All right, any other third-party library should come after that, but maybe before your site.js and before the section, because the section is going to get rendered last as per that block. Now, in our index file, we need to write the custom jQuery code that is going to, on delete button clicked, show our Sweet Alert, right? So I need a way to track when our delete button is worked. And this is JavaScript at work now. So this is a very simple example, and I will do my best to make it very clear. So I'm going to give this one a class. It's already not beautified, so while I'm at it, I'm just going to give it btn, maybe dash danger, so it will be red. But I'm also going to give it a class that says delete. So it's very clear that this is a delete button. So I'm going to set up an event to watch for a delete click event, right? So I'll say $, which is the first character that every jQuery block of code gets. Then inside of the parentheses, I'm going to have single quotes, and then I'm going to specify that it is a class called delete. So I'm watching for a class called delete. Let me be a bit more explicit and call it delete btn. So it's very clear it's delete button. And then I'm going to say dot click. So delete btn dot click. I want to execute a function. So function, and every function, that's an event. So it's going to have the data, meaning anything about who triggered the event will be stored in that object called E. And then I'm going to start up an object block with that, or a function block, and space it out a bit. All right. So just make sure you're typing it just like how I have it, every token. the placement, everything, because that if you make one mistake or miss one token, it might not be the most intuitive experience when it tries to tell you what is wrong, right? So after doing all of that, we're going to say swal, which is the name of the library. That is the name of the function that is in that sweet alert script that we have, right? So don't even try to read and understand that. That's a minified file that makes absolutely no sense as far as I'm concerned. I just know how to use it, right? So swal, open and close parentheses. And what you'll notice with me is that when I open parentheses, I close it at the same time because I don't want to forget to close it later on. So inside the parentheses, open and close, curly braces, and then create a space to start typing in there. So we have a few properties that go inside of this swal object. One, I'm going to say title, are you sure? So that is what will pop up at the top of the thing saying, are you sure you want to delete this? Well, are you sure? And then the text is going to say, are you sure you want to delete this record? We're going to display an icon that suggests that you are being warned. And we're going to have two other properties in the forms of buttons being true and danger mode being true. So this is just like a key value pairing, right? Property, value, property, value, property, value. So make sure you put on your colon, your quotation marks, and comma separate each line. So this is going to trigger the alert. Now we need to ask what happens after they've responded. So I'm going to say dot then, and then this is going to be like a delegate function, which is going to take like a delegate value to say confirm. So they either click confirm or cancel. That's what buttons true means. So if they confirm, then this will be true. If they cancel, then well, that would be false anyway, right? So after we say then, open parentheses, so we have two pairs of parentheses, and then we have what we call a lambda arrow, and then it's going to point to curly braces. And I'm trying to make sure my indentation is clear as to where each block of code starts and stops. So inside of this curly brace block, I'm going to have an if statement that says if confirm was clicked. So if confirm is true. So if they said yes, I am sure, then what do we want to do? I'm going to pause right here with all of this code writing, and I'm just going to say alert, you said yes. All right, so that's a standard JavaScript alert right here. So if the pretty alert comes up and they click yes, they get the ugly alert. Let's put it that way. All right, so let us test first and see if our JavaScript is firing as we expect it to. All right, so when we load the page and we click delete, okay, we saw something happen, but it navigated away. Reason for that is that it is still an action, right? I don't want it to be an action. I want it to be more like a button. So I'm just going to duplicate this, and instead I'm going to make it a button because I don't want it to navigate anywhere. I just want it to be a button. I don't want it to have any action. You can have the class. So I'm going to remove the btn class here, right, and make it exist on the button. I don't want it to navigate anywhere, right? So take out the ASP root, and type is going to be equal to button. So that's a little HTML coming at you. Now you notice that while I had the ASP dash stuff in there, that was full green, and it was prepared to do things that buttons don't normally do in HTML. So that's the power of these tag helpers. So now that I've made those adjustments, let's try this again. So now I have the two buttons. I have the anchor tag, the original one, and now I have the new one, which is just a button. So when I click, look at that. That's what Sweet Alerts brings to you. So that's our warning icon. Are you sure? Yes. And then we have OK and cancel. So if I click cancel, nothing happens. However, if I click OK, we get that ugly alert saying you said yes. So that is what we want. Now we need to modify it that it actually does something to trigger that deletion when we click yes. So my general technique is that I add a form to the page that handles the deletion, right? So I'm going to put a form here on the index page, it's not going to have anything tangibly in it really. So the form is going to have the ASP-action equal, ASP-action being equal to delete. And remember that a form by default is going to have the method of post. So once this form is submitted, it's going to go to the post action of delete, which, just to show you, is going to hit the post action delete, which is this. It's going to validate the anti-forgery token. So that makes it a very secure, or it's in keeping with the expected security of the deletion, right? As a matter of fact, on the delete form, you'll actually see that this delete button is actually a form happening. It's a form submission. So I'm actually just going to borrow this. Instead of typing it from scratch, let's just reuse what's there already. So I'm going to take that form. All right. Then it already has a hidden field for the ID. It has a button for submit and it has the back to list. I'm not going to keep those because I don't want anybody to really know that this form is on the page. So what we're going to do now is give this input, I'm going to give it an ID and I'm going to call it, well, ID or leaf type ID. Let me call it leaf type ID. And that's just going to help me to target it with the JavaScript. And I'm also going to give it a name. So once again, if you've ever used any server-side language, and if not, that's fine. But if you've ever used a server-side language like maybe PHP or Ruby on Rails, I don't know, but they usually require you to put in that name attribute in your HTML tag so that it can bind on the server side. So pretty much that is what our ASP-4 is doing. So when the code gets generated and displayed on the page, this form tag actually says input name equals name, ID equals name. That's what this ASP-4 generates for you. We can see that in a few. So here, because I'm not using any tag helpers, I don't even have the ID value yet because I don't know which one of these is being deleted. So I'm going to say name is equal to ID because it is expecting to see a parameter called ID. Well, actually, it's capital case ID. So let me just make sure I'm matching the case just to make sure everything is okay. So now what I need to do is find a way to find out which record the delete button was clicked for, set that record here, and then submit the form so that it can call the, let me jump over, oh, I lost the controller, there we go. So it can call this method. And it may sound complicated, but when we're done, you're going to see how easy this thing really is. So to do that, what I usually do is I put inside of the button a data attribute. So this is a nice quick way to give your HTML elements. I'm sorry, this keeps on auto-completing and giving me what I'm not asking for. So this is a nice quick way to give your HTML elements data that JavaScript can access. So I'm going to give it the data ID that matches the item.id. All right, and let me just hide the original button so that we don't get confused as to which is which. So that's the original delete button, and this is our new delete button. The user would never know the difference because they're both going to be styled to look the same way. We're just swapping it out. So when we click this button, what I want to do is prompt the user, are you sure? If they click yes, then we want to say, get the button that triggered this click. So I can say var button is equal to this. That gets the button, whether it was ID 1, ID 5, whichever button was clicked to trigger this prompt, get it. Then get the ID value out of that button. So I'm going to say var ID is equal to the btn.data ID key. So data-ID here represents the key for which I want to get that value. All right, so if I said data-puppy, then that is my key. So I would have to say btn.data with puppy as the key. That's all that is saying. So we get that ID value and we're storing it in this variable here in the JavaScript called ID. Next, I'm going to get the record. I'm going to get the leaf type ID element here. So to do that, $, once again, our JavaScript, just the same way we did this, except this time I'm getting it by its ID attribute. So $, open up, get me hashtag leaf type ID dot val. So I'm setting its value to be the ID that I just got from the button. So at this point, when the page loads, that form is there, it has no value whatsoever. Once I click the button, get the value from the button, assign it. So this is getting the value from the button. And then we need to tell this hidden that it has that ID. And then the simple last action is to submit the form. So I need a way to target the form. No problem. I'll just give it its ID. So the difference between ID and the name here is that ID is usually used for client-side stuff, your CSS, your JavaScript. Name is used for the server-side stuff. So this has to match your variables in your higher language like PHP, or in this case, C# or class. ID is usually used like in JavaScript or jQuery when you want to target an element. So here, I'm just going to target the delete form, and then I'm going to tell it you are allowed to submit. And then it will do what it would naturally do. So this is just going to simulate one of those submit click events that would have submitted the form anyway. Once that form is submitted, based on its configuration, it's going to try and get to the secure delete endpoint, and then it will carry out its operation. Wow, that was quite a bit. That was quite a few things. All of that just to bypass this page. But I think it's a nice, clean user experience to give. So let us test this out. So Control F5. And now we're on our index page. Now I'm going to delete one of these rubbish records. And when I click delete, we're getting our notification. When I click OK, look at that. It went to the secure delete and then it redirected. So what happened is that the form submitted. So it went over to this, and then it carried out the delete and then redirected to index. In case you're not sure, you can always set a breakpoint, run in debug mode. And while we're here, I'm going to take the time out just to look at what is being generated. So like I said, when you use the ASP4, let me start with this. When you use the ASP4, it's automatically generating certain attributes. So you'll see here that you get the ID's name. You didn't set that. You get name is equal to name. So name is a very, very important part of your form tags, because that is what binds over in the controller to the field of the view model with the same attribute name. All right. So back in the index, if I expand this and look underneath the table, there it is. So we have the form with the ID delete form. The action is going to all of that, and the method by default is post. It also has this input, right, with the name ID, but it's hidden. So when you came on this page, if you didn't put the form there, you would never know that there is actually a form in the background. When we click delete, and then we get this, we click cancel, nothing happens. Okay, everybody's happy. If you look at the button tag itself too, you'll see that the data ID matches the ID value of the record. Just to verify, it's details /4 edit -4, but BTN, the button, sorry, has data-ID 4. So when I delete and click OK, it submits, the JavaScript submits the form, which then hits this endpoint. After that, we can just click F5 and let it proceed with what it would do under normal circumstances. And right there, we have a very secure delete operation, and the user has a nice experience.